Hello.
Hello.
Grant. How you doing?
Hello.
Ah, I'm used to a different background. Or you must be at home.
Wait, me?
Yeah, you.
Yeah.
I seen uh, a whiteboard behind you before?
Probably in some capacity. It's over here. I used to have my desk turned another way once before, and it just kind of changed up my background a little bit to maybe add less depth.
Oh, you're just in the void.
There was a lot going on behind me, and so
Let's see. Uh, the last we met, we talked some about maybe you sharing this go around. Are you still up for that?
yeah, absolutely.
Awesome. I know Jen was looking forward to it. Same as, I mean, I am too. But, yeah.
Definitely. And I know, Brant, you had talked about deterministic UUID generation, and I'm particularly interested in that. It's so some of the feature set in Trestle is doing in-place updates, and I think that's kind of what that's around. And it's been pretty difficult to accomplish in some contexts because of the UUIDs just constantly getting updated. So you just have to work around it. And yeah, been tough.
Yeah, this is like there's so much breadth that goes into what is the norms, what is the standards of like this, and hopefully some of it can be influenced by like the OSCAL team, and they can help. But then there is things where like when you look at the documentation for unique identifiers in OSCAL, like it's a little vague. Like when are they supposed to change? Which ones are supposed to change? At least in my opinion. Maybe I'm way off base, but yeah, I've been trying to like maybe experiment with certain concepts of like the control implementation is very like, I don't know, that it's very confined. It like once you say like, hey, this control implementation is for 853 or this specific version or revision of 853, I wouldn't expect that UUID to need to change all that much unless updates are published to it. And so I wouldn't want, if the underlying thing isn't changing, I wouldn't want the UUID for that to change. Maybe.
Right. And then I wondered, like, well, how much change? So if you were to just dynamically calculate it based on maybe the contents, if you change one letter, do you want the UUID to change, or do you want it to be almost like semantic versioning? Like, is there a major change? Okay, the UUID changes. So it's interesting.
Yeah, I think a lot of that is opinionation, right? Like, what do we do? And then for me, with like Lula, to be honest, I operate on a model where I try to touch as little of the OSCAL specifics, like of how OSCAL is maybe expected to be used. But then when I augment it and do something like, I don't know, try to just thoroughly document like, hey, I'm taking a stab in the dark here because I don't have any guidance. And so somebody could come and tell me this is a terrible idea. And I'd be like, awesome. Like we'll get that into the next change. And so, yeah, I'm open for, I've got like a kind of like a short demo just to kind of belay some of the points. If you've seen some of the NIST webinars in the past, maybe this is kind of a repeat of that a little bit, but I think that we can maybe stop along the way and dissect some of the components that are valuable. But I think Jay and I talking last week, like I work on Lula. My point with these meetings isn't to drive Lula or to drive anybody to adopt Lula, but to maybe think about some of what underpins like tools consuming OSCAL in such a way that like if Compliance Trestle or another tool were implementing certain like augmentations of OSCAL, that we could probably all, do the same thing in such a way that, all of the OSCAL is ubiquitous. It can move from tool to tool, and it's not a very, I don't know, I don't want to say proprietary implementation, but like a very like strict opinionation.
Yeah.
Yep.
It's good for all the users too then.
Agreed.
And
I
I'm
don't-
coming from the same place, like as a trestle maintainer. Like I just want it to be somewhat standard between the tools. So
Awesome. Yeah, so we're already recording. Awesome. Yeah, do we want to just like kick off the demo and go from there?
Yeah, go for it. Jen did watch the video last week, and she told me I did an okay job at presenting her diagram. She could
Awesome.
have done better, clearly, but
I like it. Let's see. I'm just gonna go whole screen here. So yeah, some of the underlying like pieces for Lula to date, we really are just trying to enhance maybe the developer experience ish angle of like how do you author OSCAL? Once you've been authoring OSCAL, how do you maybe like I think do some of what our vision with this working group is to like how do you establish it as a kind of like automated governance workflow on your software development efforts. So if you have a project and we have started to integrate this with some of our own like internal software development efforts, but if you have that and it potentially meets controls, you can create this like transient flow of data that is I want to express how I meet controls in a bottom up context rather than top down, like somebody with a compliance tool scanning your environment and telling you how compliant you are misses a lot of context about how things are actually configured, how things should be configured. And so we've been kind of taking this bottom up approach of each tool can say, hey, for a given standard, if we were to look at like the control implementation, oh, I think I closed that out. If we were to look at, I don't want, if you look at the control implementation, right, for a given source of 853, you could pull controls from there and set your implemented requirements accordingly. That says like, okay, these are the ones that this piece of software meets. And so what you're seeing at the bottom here is a Kubernetes cluster I've got deployed locally. And for sake of what we're trying to do here, we have the Istio kind of control plane deployed. And then we have a mission app that is deployed. The thing that we're trying to belay here is that if you were delivering a platform that included Istio, and so if we looked at the components, if we looked at the components here, hey, like this is the service mesh component. How could you deliver an implementation for how it meets controls that is validating more than just itself? If you think about the service mesh, every time you deploy something else that interacts with that service mesh, now you need to reevaluate the compliance of the whole mesh. Because if that one thing it were to opt out of the service mesh and only operate on plain text traffic, that might be something you should be concerned about. And so we're trying to like work through that. And so for sake of how Lula works, we use links to point to a Lula validation file. And so this is a component definition. I state here's an implemented requirement such as AC4. And then I've got links here that point to a specific validation. This is a one-to-many. And so if I wanted to develop 5 different Lula validations that all belong to AC4, I could do that and it would run all of them. And I'll show kind of what that means in a second. But if we look at what is a Lula validation, this is meant to be like separate but integrated with OSCAL. but it is attempting to be a proof of compliance. If you think about a proof is two pieces. It's one, a collection of data, and it needs to be it needs to be like full context collection with constraints around the technology stack. And so service mesh applies globally to Kubernetes. And there are things that you would want to exclude, but at the same time, you want to evaluate all of the pods for compliance. And so this is the validation is two pieces. One, it's data collection, and that's what domains are. We're trying to make this very flexible. So this is the Kubernetes domain that you see here. There's an API domain if you want to hit API endpoints. We're also working on a couple different flavors of other things, just like a generic JSON or file data collection, and an admin control domain for doing like admin control automation. All things that are good, but today we support Kubernetes and APIs. So this is go and retrieve Kubernetes objects with some guardrails. It's a read-only activity. So there isn't the potential that a user accidentally modifies the environment with this resource collection. We do allow a separate activity under the Kubernetes domain, which is I want to test by injecting a change to the environment and see how it responds, right? So this is how we test things like Gatekeeper and Pepper and Caverno to date, where we say like, hey, we know we have a policy that prevents a pod running as root from running. We know that policy's out there, but unfortunately you can't use a lack of enforcement as compliance. And so we don't use enforcement engines for stating compliance. That's why we have Lula. We use enforcement engines for enforcing security. And then we have Lula to validate the compliance. And so if we have a policy that states no pods can run as root, we can actually use Lula to try to create a pod as root. And the output should be that, hey, the validation engine, the policy enforcement engine denied that activity. And hopefully everything should return fine, and we clean up. The outset of that is if the policy didn't actually work the way you intended it to, it could go, you could be under the assumption that things are working correctly when actually they are not. And so it's a twofold. It's compliance, but also we use this for testing that like all of our policies are working as we expect them to. So that's another flavor of how this is kind of fun or exciting. But in this example, I want to get all of the pods. You can see which pods are running currently. That's all great. There are a number of pods there. We collect all of this data and then we pass it to a provider. And a provider is a library implementation of a policy engine. So you can use OPA. We also support Caverno if you want to write your policies in the Caverno policy validating policy language. And so either of those work. Particularly, we find Rego is actually pretty well suited to solving a lot of compliance related policy evaluation. And so we've got this policy here, and it's going to take in those pods, and you can see how it's going to start processing where it says we want to validate something. In our evaluation, we consume, where's the best place to see this? A variety of different spots here. We check for exemptions. If a namespace is exempt, why is it exempt? Those are things we want to print out. So we print out which namespaces were exempt. We print out the actual output here. And or things like if we are expecting a Istio sidecar proxy in a pod and it wasn't found, again, we want to print all that information out using native Rego. But besides that, we would look for input.pods here. And so it's going to basically process all of the pods and check for the proxy sidecar. If we're doing MTLS with the Istio service mesh, We would expect every pod to have the Istio sidecar if you're not using the ambient mesh option. And so this wouldn't apply to that. But for all the sidecars, we want to check and make sure it exists. Awesome. I've done a lot of talking. Let's maybe do a little bit of showing. And so let's close this out. If I've got this here, I'm in this compliance directory where the component definition exists. If we look really quick, the component's there, the validation's there. The component has a link to the validation. Wonderful. Lula has a variety of commands. The one we're going to look at today is validate. And so this is where we run the component definition through Lula, and it produces the assessment results model. And so if we run Lula, having a hard time typing Lula validate, and we pass in component, you get a couple different things printed out. One, log files is great. We found 7 implemented requirements, and there was one runnable Lula validation in there. So we executed that. This is just the quick CLI output, just to give you some high level what happened. And so you see some things. We're working on improving this output in particular, but you see UUIDs which match to essentially findings. And so you can see this one's satisfied. If you are operating on a component definition implemented requirement and there is no Lula validation, there was no evidence to check. And so Lula takes the default stance that if there's no evidence to say that something is satisfied, we're going to report it is not satisfied, just to be kind of like safe, I would venture to say. So that's the output from the terminal aspect, but from the actual results aspect, we have the assessment results model. It's kind of templated for some things that you might need to fill in, like your system name. If you have an assessment plan, Lula is looking to generate assessment plans in the near future. But then you get your results, right? And so you have a result for your latest assessment, and then you have findings. Wonderful. AU3, it has no observations, no related observations, so it's not satisfied. But we get to AC4. We see that there are related observations here. Here's the UUID for that observation. This Lula validation is essentially what's in the observation. Because it returned satisfied, now the finding is satisfied. Again, that's an AND operation. And so if you had 5 Lula validations and 4 of them passed and 1 of them failed, well, the AND over all of that is not satisfied. And so we would report not satisfied. But we can go and look at these observations here. You see, this is some of the things we're printing on. The remarks say all the pods have the sidecar. Here are the exempted namespaces. And so there's a variety of things here. The Istio system namespace is not Istio injected because it's natively integrated with the mesh and the control plane. Cube system was exempted, local path storage, yada, yada. Like these things were exempted. What you'll note is like the mission namespace is not exempt. So that was actually processed. That's great. My running joke is, how do you know I didn't just make a report satisfied every single time and it's just not hard coded to do that? Would be to like, okay, well, let's inject something that should report or make the whole cluster or that control specifically not satisfied. So what we'll do is we'll look at an example where, actually, before we do that, if we get all of our pods again, we've got the mission app namespace, we've got the mission app. If you know what you're looking for, you would see, hey, there's 2 containers in this pod. One of them is the Istio sidecar proxy, and one of them is our mission app. That's how we know it's all configured accordingly. If we were to run another pod, let's call it the mission app drift pod, we'll put it in the mission namespace. I guess this is the mission namespace in the mission app. We'll put it in the mission namespace. We'll use the same image that it was using, but we're going to explicitly take it out of the service mesh. And so we'll use the label for pods to not have Istio inject the sidecar proxy. So if we look at that, awesome. We can now see that, hey, we have a mission app drift pod deployed in our cluster. It looks different from our regular mission app, and we kind of know why. But if you're somebody who's evaluating compliance, or you just have Lula running on some cadence, daily, hourly, every minute, or on an event-driven kind of like webhook, kind of like up to you. But you would notice something is wrong here, or maybe you wouldn't until Lula scanned your environment. And so we would go back to this same command. We have changed nothing about our validation. We changed nothing about our component definition. So our compliance information is all the same. We've only modified the environment, or the environment has undergone some drift. And so we can run that and see the same outputs as before. Still 7 implement requirements, 1 Lula validation. You see we evaluated and it is not satisfied now. That's kind of our first glimpse into something changed. Okay. That's great. If we were to go and look at our assessment results, we would see a new finding or a new result in here. And that would be, it would be the first result in your list is always the newest. And so we would see, if we looked for AC4 here, not satisfied, still has the same, well, it still has a related observation, i.e. this one is not the same because we're dynamically generating UUIDs. We come down here, a Istio sidecar proxy was not found in pods, and then it lists the pod that it was not found in. That's helpful. It helps you debug and say, okay, something's wrong. Why does this mission app drift thing not happen? The piece that I haven't shown yet is that the exit code for all of these operations, whether they are passing or failing when you run a validate, is always the success exit code 0. Lula validate is kind of an objective, like what's happening. The piece where we put Lula to work with, say, like failing our pipelines, if this is a process in our pipelines, is to say, okay, well, how do we then evaluate? And what Lula does is evaluates 2 results from the assessment results together against each other, and use one as a threshold, essentially. When were you the most compliant? And so what we would do then is consume this assessment results that we've now been dynamically generating and populating. And if we run that in our first execution, AC4 was passing. In our second execution, AC4 is failing. The first one is now deemed our threshold. If we were to go back and look at our assessment results on the bottom of this one, we add, I don't think it, something is, I'd expect this to be true here. I'll have to debug why that's not the case. But that threshold should be changed to true. And that would be what establishes your compliance from here on forward. Something funky about that one, but nonetheless, if we were to then reset our environment, get pods and do a delete pod mission app drift, we can delete our pod that is making us uncompliant. We'll rerun validation again. Quick glimpse at this is saying, hey, something is right again with the world, satisfied. And then we can rerun, evaluate again, and see that we are now back to a passing threshold. And I think evaluation passed, new threshold identified. And so what it did is went and updated our threshold so that it actually is established this time. And if we looked at this one here, this is what you would expect to see on your threshold. So for every evaluation here on forward, If you are equally compliant, this is still going to remain your threshold result. If you are less compliant, it still remains your threshold result, but this is the one you compare all of your newer results against. And if you are more compliant, Lula sees that you are more compliant and then updates this this prop to now be threshold false, and the newest result, which is more compliant, to have threshold true prop set. I'm going to stop there for a minute before we maybe look at just some of the other commands really quickly, but this is really like the core of Lula is this operation. This is what we put into our pipelines so that we can evaluate all of the goodness of things, but also get this nice output of like, even if we're not automating all of these, which ones are we aware of that exist in our OSCAL, so that we can report on those, we can start to enumerate over them and figure out how to eventually make each one passing. So yeah, I'll stop here for questions before maybe moving on.
This is cool. I have one question about what your vision is for how this would get aggregated up through an SSP to an assessment plan, or are you planning to go straight to the assessment plan?
That's a great question. It's something, actually, funny enough, I think I've got this in an ADR. I don't have that I can show off, and not show off, but like I can point to for sake of like maybe some of the intent. And again, if at any point along the way somebody can invalidate something that we know, I would love that, or something that we think we know. But we've got this ADR here, basically trying to like capture like what is the vision for all of the different artifacts. And I think that largely, and I don't think it's a novel take, that you are pulling context from multiple different models to ultimately like be transient or flow from one model to the next, whether that's strictly with the import statement or whether it's actual like programmatic, like I am taking context from a component definition to create my assessment plan. But I think the overall idea is Mermaid's kind of the best I've got to work with in Git at the moment. But to have these development repositories that each have their own component definition, they each have their own controls. And when you want to target an environment, right, that's when I believe like SAPSAR, POAM, and SSP come into play. You're actually like targeting an end system. You would say, okay, well, I want to create a component definition that consumes all of these, whether it's a capability or another component. But then I want to do some things with it. And we have the idea of like currently taking all of that context and having it flow into an SSP. I would call it a template. I think there's going to be things missing that you would have to go and fill in. It's certainly not an end like silver bullet for your SSP is done, you're ready to go. But it gives you something to start with and consumes all this context. And then if all of your component definitions have validations for their controls, I want to generate an assessment plan from your component definition. And then instead of like a Lula validate and a component definition, I think in the next logical step is like a Lula assess and an assessment plan. And then you would be assessing an assessment plan at that point in time and then producing assessment results just like we do currently. And then the last piece of that, I guess, is once you have assessment results from your assessment plan, you could probably use that as some piece of evidence for generating your plan of actions and milestones. So everything that failed maybe should have an entry in your POAM. Maybe. I'm still learning a lot of this.
Yeah, this definitely makes sense. And I see like the component definition staging being valuable, maybe from a component supplier point of view. If you want to test, hey, I'm giving this to my consumers, I want to make sure that what I'm giving is actually passing in my demo environment. So that makes a lot of sense.
Yes, absolutely. So I think we very much like the idea that we want these like component definitions for various pieces to be sources of truth, and that's great. And so that you could link to them, right? Import component definitions and have that be maybe like an external reference to another component definition somewhere else. My I don't know, my purview or a lot of the work that I think I focus on day to day is the air gap piece of this, where if you're going to go to an air gap, you don't have that connectivity anymore. So we always want to be slightly cognizant of that case happening. And so the other piece for like, how do you make this highly portable? Because you could have, if this is, I don't know what, 5 or 6 controls, 1, 2, 3, 4, 5, 7 controls. There may be 5 Lua validations per control. And I don't want to have to give somebody like a blob of like files, right? That would be 35 some odd files and the component definition in order to like make this portable, is just to like think, well, okay, well, one thing that we think we might want to look at is like composing OSCAL. So if you're pointing to multiple different component definitions and you import them in that import component definitions top level key in the component definition, I don't have that to show off today. But we have a compose action, which would allow you to essentially take in a component definition file and then output something like whatever you wanted to call it, component composed .yaml. It would compose it of all the external links and basically bring them all local to your OSCAL. Some of that, again, is very OSCAL specific. If it's all OSCAL and it's all the same model, we can probably perform a merge activity and like smush some of this together. There's going to be edge cases there. But if we think about the validation files, we wanted them separate such that I can have a schema for a validation and you can get like quick developer feedback on when a validation is properly formed versus malformed. But then when I'm ready to take this to the air gap, I can run a compose and you can see we took that validation YAML that was in here and it's basically just injected it into the back matter. So at this point in time, you've placed this validation into a resource through the description multi-line markup. Not my favorite implementation, but it accomplishes a need. It accomplishes like, how do I make this data highly transient within OSCAL? And so all of this data exists here. It's OSCAL schema compliant. It has its own UUID. And so if you were to go and look for that UUID in the component definition, what you would find is that external link that you had previously to that file has now been swapped for a UUID reference for something that now exists in the back matter. Hopefully improve some of the composability and portability problem statements a little bit. Yeah, I think that is the core of like what I wanted to show off. The other pieces of this is like, we are trying to be, I don't know, tackle just 2 problem statements. Like how do you come by OSCAL, and for those who haven't worked with OSCAL, like where do they get started? How do they get started? And how do you help people use OSCAL as just one problem statement? The other problem statement is the automation assessment. So automation is the validation side of the house. And it's what we see is like the dev command is like, I just want to develop validations, more of like the technical piece. And so we have a number of like Lua dev commands for like, if you want to get resources and interrogate which resources a validation is going to look at. If you want to lint a validation, if you want to run a validation in isolation, you could do that today. We could run Lua dev validate and pass in just the validation file, and you would get your observations that you saw in the output, and you could see, hey, this is passing. There's nothing failing. Wonderful. So that's kind of our Lula dev command. Generate right now is only supported for components. But if you looked at our diagram, like what we want to do is be able to like specify different targets, which is like, I want to generate a component. Wonderful. What do you need to do that? We do it straight from a catalog. So you provide like the catalog source, which component you want to title it, which requirements or i.e. controls from the catalog you want to basically port over. And so with a one line statement, you could essentially generate this component definition, not the validations. I don't foresee a future without Gen AI that you could create those, you could generate those without context. But for all the rest of this stuff, like if I know my service mesh meets AC4 and 4.4 and 4.21, that's something that we can generate from a catalog, I believe, pretty easily. We want to extend that, generate SSP, generate assessment plan, generate, all of the above, POAM, etc. So we've got intent to keep building that out. And then I think outside of that, it's just other like OSCAL helpers, right? So I showed compose for composing OSCAL into a single OSCAL model file. If you want to lint OSCAL, this is like more of like a JSON schema linting activity, not maybe the full breadth of what the OSCAL CLI provides for rule sets, but it does it whether with whatever version of OSCAL you have. And so if we were to run Lula tools lint and pass in the component definition, you would see, hey, validation result. This is a valid OSCAL file for version 112. Awesome. I don't think I'm really using any fields that are different from 112 to 111, for instance. And so if I change this back to 111, for instance, it would run it against the 111 schema. Or it should have if I had saved it. OSCAL version. Oh, this is the composed file. That's why. Change that version. Run it through here. You'll get just some basic heads up warning. Hey, this is version 111. We linted it against the 111 schema, but the latest is actually 112. This is a warning for you. You should upgrade. You should consider upgrading. There haven't been many breaking changes since like version 1 of OSCAL, and specifically like 104 forward is the change sets are relatively small. There's things that we want to look for. But one of those things that we can do is Lula tools upgrade, which will let you pass in what version you want to upgrade your OSCAL to. If you leave it default, it will default to the latest version of OSCAL. And so we just kind of remove this churn or overhead of like, what do you need to know about OSCAL before you update all of your OSCAL artifacts? And so Lula tools upgrade, pass in a file. Again, we'll pass in this component.yaml. It'll upgrade it to 112. And it's doing more than just modifying that version string. It's like comparing your data against the latest schema. If there were problems, we want to prevent data loss. And so if there was a breaking change, we would then print out a variety of things like, hey, this data changed, this data is no longer present. You might want to go and investigate that. But if everything is backwards compatible, then your upgrade should hopefully just be a one CLI command away from upgrading all of your stuff and not having to concern yourself maybe of what all of those updates were. If you are a OSCAL consumer instead of like an OSCAL developer expert. So that's Lula lint upgrade. And then the last piece, which we talked about in the beginning, is just a quick UID generator, just to make life a little bit easy. If you want to update some UIDs manually, or change something, when Lula sees that something changes, we've been slowly injecting like, hey, let's go ahead and update the UID when we believe it should change. Something about this document changed, we should update it. We're still trying to figure out what all those edge cases are, but nonetheless, we got a UID generator, and then you can make it deterministic by passing in an additional value here, which is just like, what do you want the UID generator for, like, to be? And so I could pass in like my name. Awesome. If I run this time and time again, right, I get the same output. And the only place that I can say that we have put that into play to date would be one in the automation, when we derive a control implementation source. This UID should match this source. So this is a local file. Ideally, I was doing this offline, so I had to use a file for doing that. But ideally, you would point to like the upstream release object artifact, right? You could point to a specific version, hopefully not main. Hopefully it's a tagged release or a commit hash of a raw file. But nonetheless, if we were to run this through here, UID gen, I would expect that this produces the same 0655, 19276. Yeah, so that's the only place it's currently in play in automation for determinism. We do use it for other things, like if a parties field is meant to be common across many different OSCAL files for the UID or some other piece of information, maybe that's worth standardizing on. But any of that may be entirely incorrect and something that we need to change. And so we're just trying to expose that data. So yeah, I think that covers a lot of what I had. I'm totally open to comments or questions. But other than that, I think the real goodness that I hope to get from like this working group and some of the other ones is just finding commonalities in, like, what do we want to do? Is it authoring OSCAL? Is it modifying OSCAL? Is it OSCAL tooling that makes somebody's life a little bit better? Or is it automation, which maybe comes in different flavors? What tool do you want to run automation with? And maybe it's one of many tools.
Yeah, I think even something you said here where you're doing a generation and then it would be helpful for a user to continue on with the authoring process, that could be a combination of tools. I see overlap in a good way with the validation and the rules and checks that Trestle has in place, but that's, I think a lot of the OSCAL mini workshops I've been to, almost everybody who presents has a way to do rules. And I think that from our talks with the NIST folks, they're really looking for more feedback from the community on how to do rules. And I think that's really the only difference I see, other than I think the observations, the way observations we're doing that is like slightly different, but just barely. I would have to go back and look. It might be pretty similar, but I believe we're filling in the relevant component information, but I can't remember exactly where off the top of my head.
Yeah, very cool.
Yeah.
Yeah, not sure exactly where to go next, but I'm kind of hopefully I like that this could be maybe the medium or venue or working group activity that kind of helps with like what what are the assumptions to date on like how to accomplish X? And if X is like put some piece of automation into OSCAL, it would be cool to like catalog what people have done to date, and then find ways to do things with multiple tools. Because like today, Lula is probably pretty specific to a Lula validation, but that doesn't mean, I guess, that Lula can consume OSCAL wholesale and do like another check with another tool. It'd be kind of tool inception, but a lot of potential.
So what other, who else might be implementing these types of things that we should invite so that they can show us how they have done this, and we can tell them, no, we came here first. This is the who, can you guys think of anybody? Or maybe that's some homework and we figure it out on Slack and stuff like that. It's like, because that I do think that what you were just saying is good. And then like, it's, if we get others, pull them all together, I'm sure some of us are going to go, ooh, I like that better than what I did. That would make my life simpler. And then as we all start, we're seeing how each other has done it. I think we can naturally converge on some standards. I think we might naturally converge on some asks back to NIST for OSCAL.
Yeah, that's a great question. And I find this space like really exciting because there isn't a whole lot of options available. And so like every time like you do something silly, like I want to generate a component, and it like even our implementation to date is pretty vanilla, but it's like, where else can I go to do that? And you pick up on me like these little onesie twosie like helper functions or additions to your tool. And I haven't seen a lot of other tools combining, like, is their job to be like an OSCAL authoring tool versus automated assessment versus something else that maybe doesn't exist today.
Mm-hmm.
Besides Trestle and Lula, I haven't been tracking a whole lot of other solution spaces.
There might be AWS Security Hub Analyzer. And I saw an OSCAL mini workshop on that. And if I'm not mistaken, there was talk of rules there. And I have the link. I can link it in the Slack. I think another place we could look is OSCAL.io. There's tools there. I'm not sure if they are particularly in this space of bridging compliance and policy. So maybe you're right, Jay. Maybe it's some homework that we come back.
Maybe another. So there's who else is independently trying to solve the same problem? And that's one way I think to gain some different perspective. I did bring up. I was really kind of thinking out loud yesterday in Slack about STIGs published by DISA, the DISA ones, not like ones published by Red Hat, because the ones published by DISA are actually very much simpler, and they've got a large catalog. So would trying to take STIG and convert it, like how, if we were trying to do that, how, one, that if it did work out, that'd be pretty cool that we could just go, and then all those things would be available to make use of. But would the variety of they call them controls and then rules, and I had it open. I forget their terminology, but all of the the ways that they do it, if we convert it into the way we're trying to do this with OSCAL, I wonder if it's not always the same, like it always is the same conversion. This maps to this maps to that maps to the other. And it's always that way. I kind of suspect it won't be. I kind of suspect there's going to be some deviations. And I wonder if those deviations would push us into different scenarios that force us to see, what the way we were going about this wouldn't handle this very clearly. Now I have more to think about. Now I have, I'm doing this in a controlled scenario as opposed to it's out in the wild. And now I'm like, oh yeah, we didn't, you're right, customer. We did not think of that. And yeah.
Yeah. Would you see that like first layer as being like the catalog and like take a STIG and produce like a catalog of like, what's the intent of the STIG, and then allow, I don't know what the component would look like necessarily just yet, but like, where do we get started? Like, where would that get started?
If I understand correctly, and I don't think I do. Also, I'm late for a dentist appointment, but I think it would start with the A STIG is probably a component definition, if I understand correctly, and then there would be the, what are they called? Implementation. Control what is it called, Jen? I was asking you the other day. I always get tripped up on the terminology. I haven't got it memorized yet.
It's like an implemented requirement.
Yes.
Oh, yes, that is what we were talking about. Implemented requirement.
Yeah, that one. And then I think that becomes like the check that they have. Like so. I'm going to go look if I'm picking on whatever. I'm going to go look in this file. And I'm going to use a pattern checking thing to see that this exists in there. And if it does, cool, we pass. And if it doesn't, we don't pass.
Cool. I think I have not been putting things in the meeting notes. And so I'm going to retroactively go back and do that. But I think this is one that I might dissect a little bit more in those meeting notes, because I think I have a couple ideas for like catalog versus component, and it'd be cool to bounce ideas back and forth.
Yeah.
Yeah, because I wonder, sorry, go ahead. I was just going to say, I wonder if a STIG is actually capturing multiple models. It might not just be a component definition. It might be a component definition and everything above that, possibly. So, yeah.
But I was kind of, my first objective was if we can, if it gives us some more diverse, like, use cases to push our current thoughts on this is how you use OSCAL through, then it might teach us something. And then optimistically second, if those things work, then like if we could translate their catalog of STIG stuff into OSCAL stuff, that would also make it way more attractive for anybody else to be like, oh, you know what? I do want to adopt OSCAL.
Yeah. I think something else that might be helpful, and I'll say it quickly because I know you're late, Jay, but as we're going through this, it might be helpful for us to catalog like what makes sense for us to standardize on and what makes sense for it just to be a tool opinion. Mm-hmm. So like it sounds like rules or something that we should all discuss and standardize on to make it easy to use between tools, and then possibly UUID generation. But I'd be open to see what others think of that. So.
Yep.
Agreed.
Cool.
Ooh, and we could. I noticed you guys use ADRs also, mm-hmm. And we could do an ADR for all of those things.
Like it.
All right. All right. I'm gonna go get my teeth cleaned. You guys do something else that's more fun than that.
Awesome.
Bye.
Bye.
Yeah.